Have you ever heard of a muon? It's a subatomic particle that has the weight of about 207 times of the electron. So that's the weight difference between this phone and that electric scooter. Its lifespan is about 2.2 microseconds. So within the duration of this one snap, a muon can decay or break down 500 times. And every minute, hundreds of them are crashing right into us. Ow! I just felt one. No, I'm just kidding. We can't see or feel them. Recall anything? Yes, this is the Muon. During the 1930s, perfect. A physicist from Caltech named Carl Anderson discovered the muon while studying cosmic radiation, which is basically radiation from outer space. As this radiation hits the Earth's atmosphere, it produces subatomic particles, one of which is the muon. These naturally occurring muons have special properties that make them useful not only in science, history, but also astronomy. Think of these muons as spies. They can go deep into matter, unlike other particles, and tell us things that we can't see from the outside using our current technologies. For example, when muons interact with elements that have high atomic numbers, that is, a high number of protons, they'll slow down and get deflected. This is due to the Coulomb force. This force explains how opposite charges attract and like charges repel, much like these two magnets. Due to this force, when negatively charged muons come into contact with electrons, they get deflected. And since a high atomic number means more electrons, muons will react more strongly to elements further down on the periodic table, such as uranium and plutonium. The really great application of this, which is known as muon tomography, is that muons can be used to detect nuclear materials, such as uranium, and this can be used for border safety and environmental protection. Scanners placed on either side of the unknown material can show us the muon's pathways, and if the muons change or deflected off their original pathways, we can tell that the material is a nuclear material or an element further down on the periodic table. And just like this, these spies have provided us with critical information relating to safety and protection. Just as muons react differently with elements of different atomic numbers, muons react differently based on density, or how packed something is. This process is called Neography, which is similar to X-ray, but it's much more powerful. As muons pass through matter, they lose kinetic energy, the energy of motion. The more dense the matter the muons pass through is, the more energy they lose. This was used in 2017 when researchers in Egypt mapped a 3D image of the Great Pyramid and discovered a hidden chamber within. And in just April of this year, Fermilab's Muon G2 experiment hinted at a new discovery in physics. Just as tops wobble when they're spun, muons wobble too when they're placed in a magnetic field. However, the muon's wobble was different from what scientists predicted, and this suggests the presence of unknown forces or particles. Muons have brought us closer to unlocking our universe's secrets, from pyramids to volcanoes to even life beyond our planet. And who knows, muons just might be the missing link to discovering our universe's most hidden secrets.